All right, so let's take a look at one more from yesterday. But notice that you'll be able to finish up yesterday's homework then. But notice it is asking for the second derivative. We get to do it twice. Okay. All right, so let's start. Remember, the function is an f function. When we make our list, it's just arbitrary. Okay, it's just general. This f of x is simply representing the first factor, the first thing that you're multiplying. Okay, don't let these two, they're independent of each other. Okay? All right, and so what are we going to write for this f of x? What's the first thing we're multiplying? X. Yeah, so take advantage of it. I mean, we have to do it twice, so hopefully they're not going to give us something super hard. All right, and then what is its derivative? That's even nicer, right? 1, okay? And then g of x is just in general standing for the second thing that we're multiplying, and that is cosine. And so its derivative of cosine is negative sine. And then the pattern, unfortunately for multiplication, it's a little bit harder pattern. We have to remember that it is, okay, the first times the derivative of the second plus the second times the derivative of the first. And so then we just go plug that in though. That is x. Derivative is negative sine of x. Notice you have to have parentheses there. Make sure you don't want it subtraction. That's multiplication. And then g of x is cosine, and the derivative is 1. If you write it, that's fine, but multiplying by 1 doesn't change anything. Okay. All right, but let's label that. That is just the first derivative. Let's go ahead and rewrite it one more time. I'll move that negative all the way to the front, then I don't have to have parentheses. Negative x, and it won't get lost, hopefully, and then plus cosine. So now when we go to take the derivative of again, we have terms now. We have to look at this term, and then we have to do this term. So when we look at this term, what do we have? Product rule, okay? So we have to do the product rule, but after we're done with that, we can't forget about the next term. Remember, for adding and subtracting, you get to do it one at a time, okay? And we usually saw like 3 or 4, and then we did one at a time. So here it's kind of nice, there's only 2, but then sometimes we lose this one. Okay, so we're gonna do this one first, then we're gonna do this one. For adding and subtracting, it's nice, you get to do it one at a time. It just so happens that the first one happens to be the product rule. So let me, I think, yeah, so let me, I'm just gonna rewrite this. Okay, yeah. Let me just rewrite this up here. So this is the first derivative. And it was what? I want to make sure I had it. Negative x sine of x plus cosine of x. Does that look right? Okay, so now the second, well, before we do the second derivative, when we do this one, we have to have an f of x. What is the f of x? And again, remember, that's just generic for the first thing we're multiplying. That is negative x. Yep, just make sure you take the negative with. Its derivative, just be careful, its derivative is negative 1. So the negative does stay around. G of x is the second thing, sine. We're not even here yet. Okay, we're just working on that first term. And its derivative of sine is cosine. All right, so then we do first times the derivative of the second plus the second times the derivative of the first. Plug it in. Negative x, derivative is cosine of x, plus g of x, which is sine, derivative, which is -1. Just make sure you don't write -1, it's times, so put that in parentheses. That covers this guy. Now, what do I still do? Now I move on to the next term, and that just happens to be cosine. So now I get to do that, but that one's a piece of cake. It's just cosine, so its derivative is negative sine. Okay. So technically it's a plus coming from right here. And then this just happens to be negative sine. That answer is not too bad. This I probably would just leave. So this is finally the second derivative. Negative x cosine of x. Take a look, like when I rewrite this though, maybe I'll even do it here. Negative sine of x, and this is minus sine of x. Those are like terms. A negative sign and a negative sign takes us to -2 sine, not Tucson, Arizona. Who's going to Arizona right now, especially with the weather cold, but Tucson, okay? But even if, even if you could get here, that's pretty good. Okay, the other was just a matter of collecting like terms. Good, okay, so that'll help you with last night's homework. It's probably good to review anyways. All right, we got to do first times the derivative of second plus second times the derivative of the first. Now we get to add on another rule. Okay, who's excited? Maybe tomorrow we'll have maybe a little bit more time. We'll kind of talk about what you have to remember for the test and what I give you. Okay, I think the 4 things you're you'll have to remember the power rule, but we do that so much. And then you will have to write down the product rule and the quotient rule, derivative of sine, derivative of cosine. Okay. But what I have you do is I'll have you do that early and I'll grade it and then I'll give it back to you. So the day of the test, you will have the formulas in front of you. Does that make sense? But prior to, probably that Wednesday before, you'll have to fill those 4 things in. Okay? But I'll correct it. So the day of the test, you can just use your formula sheet. All right. So section 2.4, part 2. We're going to spend time on one thing, quotient rule. What does quotient mean? Answer to a division. Okay, so what are we going to do when we have division? I think we're ready to go. So the derivative, if you have f of x divided by g of x. And again, that f of x and g of x are just simply representing numerator and denominator. Okay? Is equal to g of x times the derivative of f of x minus, believe it or not, that adds a whole nother twist, just more things you have to remember, f of x times the derivative of g of x all over g of x squared. Now, as messy as the bottom is, we usually don't do a whole lot with it. So we're just going to write g of x, and we're just going to square it. Okay. Every once in a while, we might see something a little bit next week where we'll maybe do some canceling with it, but don't let the bottom, even though it looks messy, the top is messy enough. We usually kind of just leave the bottom. Okay. Anything else? Oh, so when I remember this, I remember there's a G at the beginning, there's a G at the end, there's a G at the bottom, and each one is different, right? So the first one is regular G, the one at the end is the derivative of G, and the bottom one is G again, but this time you have to square it, okay? So kind of, if I say something about a triangle, that's how I remember it. G at the beginning, G at the end, but it has to be something different. So derivative of G, and then on the bottom, it's G squared. And then remember these two, they're always opposite. So if I write G, that has to be the derivative of F minus F, derivative of G, and then over G squared. Some people do stuff like low, high, high, low. Does that make sense? Low meaning the denominator, high meaning the numerator. If you want to do something like that, you can. We'll see if someone comes up with something else, that's fine. Okay, so let's take a look. We're going to go right to examples. Find, guess what the directions are? Find the derivative. Okay, find the derivative. Yesterday, it said differentiate, same thing. Okay, find the derivative. We'll just put of the following curves. Of the following curves. Our book loves the word curves instead of like functions or graphs. All right, so y equals x squared plus x minus 2 divided by x to the third plus 6. A lot of algebra, because guess what we're going to have to do here? I'll get my hand out of the way. We're going to have to multiply, do all the foiling, okay? Same thing here. Okay? And we have to worry about distributing a negative. So the numerator is just a lot of algebra. A lot of places to make little mistakes too. So just take your time. Oh, let's see, we're running out. Let me slide this up a little. Let's at least get our chart going, and then I'll switch it to the next page. So what's our f of x? F of x is simply the numerator. Okay, remember again, f of x and g of x are neutral. They're just a way to say, hey, we're talking about the top and the bottom, numerator, denominator. Okay, so x squared plus x minus 2. What is the derivative? Roll it down, subtract 1, so 2x. And then that goes to 1, and the negative 2 goes to 0. G of x is the bottom. The denominator, x to the third plus 6. And what is its derivative? 3x squared. 3x squared, roll it down, subtract 1, and 6 goes to 0. So it's always nice when you see a number, right? One less thing to worry about. Okay, good. All right, so now, I think I could just slide this up. Let's slide it up. It might be good not to see the quotient rule, so we'll just say it again. Maybe I can even sneak it in here. G times the derivative of f minus f times the derivative of g all over g, and then you have to square it. And we have the G, the 3 different things going on with the G's, beginning, the end, and the bottom. All right, then it's just a matter of taking some space to plug it in. G is x to the third plus 6. Derivative of f, 2x plus 1. Now, just be careful here. Maybe we should even, yesterday we had plus, so we didn't have to worry. These red parentheses need to always go in. Let's even back that up. We usually don't write it in our rule like this, but maybe we should, because we need those every single time. Doesn't contrast too well, but because we're subtracting a quantity, the quantity must go in parentheses. So don't forget it. We really don't need it in our rule until we start putting in the numbers, but it might be good to have them in it from the beginning. Okay, so minus, and then the bracket. All right, now let's go back. F of x was that trinomial. And then the derivative, the derivative of g, they try to give us something pretty nice. So it's just one term, 3x squared. So that's not too bad. And then all over, don't forget all over our g, which is x to the third plus 6, and then square that. Don't worry about writing that out twice and multiply. Don't worry about that. We just have to multiply the top. All right, so let's FOIL. So x to the third times 2x is 2x to the fourth. X to the third times 1 is x to the third. Inner gives us 12x, and last gives us 6. Okay, just a simple FOIL. First, outer, inner, last. Okay, here we're going to do minus, and we're still going to have the bracket. And then what do we get to distribute here? Even though it's at the back, you just have to distribute the 3x squared. So it has to go to all three, but it's just one thing. It's just one term. So that, and what do you do with the exponents when you're multiplying? You add them. So 3x to the fourth plus 3x to the third, x squared and another x, just add those exponents, minus 6x squared. And then we have to take one more step and distribute the negative. Okay. I think it's just as easy to, I know it's a little annoying to write it twice, but that way you won't get it wrong. If you want, you could do like plus and then make the same sign change that way. If you don't want to rewrite the whole thing, you could do something like that. We could just do this, negative 3x to the fourth. Well, I'd probably, you know, if you want to leave it like that and just kind of look over here, depending on how good you are, I'll probably just write it down. And I did forget, and I left it out on purpose, don't forget the denominator. I kind of put that on hold because I just got to clean all this up and then we'll bring it back in. It's up to you if you want to read, if you want to be more official and write it down right away, that's okay. Okay, all right, so what do we have? A fourth and a x to the fourth, 2 minus 3. So now we're just doing, simply collecting like terms, x to the third and a 3x to the third. So, and if these are not in order, so that would be 1 and 3, so 4x to the third, that's okay. I know in algebra, we really wanted them in order. It doesn't matter so much here. Like, you know, 4, 3, I try to do 4, 3, 2, 1 or the reverse, but it doesn't really matter. It's just however you can get them all together. Let's see, are we okay here? All right, what else do we have? This should be, oh, yes. I said to do it and then so I did the first one, but what should this be? The whole reason I rewrote it and then I miserably failed. This should be minus, and what should this actually be? This guy should be plus. Yeah, back that up. This guy should be negative because you have to distribute. That's the whole reason for the parentheses. And then this guy has to be plus, so make sure you have that as plus. All right, so now when we collect like terms, this will give us what? All right, let's try it again. Negative x to the fourth, 1, now the negative 3, that should give us, oh no, this guy's negative 3, so negative 2x to the third. That looks better. What else? This is the only x squared, and it's positive. Now that's corrected, right? It's positive, so plus 6x squared. What else? Do we just have the 1? Yeah, we just have the 1, 12x, and the 1 plus 6. Okay, and now don't forget all over x to the third plus 6 squared. Why did we find that? What is that going to tell us? That's the derivative. That finds us slope. It's a little messy. This graph isn't too bad. But to find the slope at any one point on this graph, you got to plug it into this. And that gives you the slope, and every slope is different because it's a curve. All right, let's try it. This one actually is a little bit shorter. We should have done this one first. All right, so if we made this one, we're in good shape, okay? So this is probably the hardest. I think a little bit later it gets a little bit harder, but. All right, let's try. Are we ready for another one? They call this g of x. All right, so x squared minus 2 over 2x plus 1. Now remember, when we make our list, we're not referencing this g of x. We're just simply talking about numerator and denominator. Okay? So f of x, what is f of x? That is the numerator, x squared minus 2. What is its derivative? That's not too bad. Roll it down, subtract 1, 2x, and the negative 2 goes away. All right, g of x, remember this is just talking about the denominator. This is our general numerator denominator. So this is 2x plus 1, and its derivative is 2. Okay, and then we just have to remember the pattern. Starts with g's. Remember, g's are our corners on our triangle. So g, derivative of f, minus, let's put in the parentheses and actually use them this time. F, derivative of g, and then all over g squared. And did we see on that last problem, we kind of just did that bottom and we just kind of left it. Thank goodness, something we can leave. All right, so that, and then it's just a matter of plugging it in. G is 2x plus 1. Derivative is 2x minus bracket, and let's use those this time, x squared minus 2, and then the derivative is just 2. And then all over g, which is 2x plus 1 squared. And I can mark this as the derivative if I want. Okay, now it's just a matter of cleaning up. Now, no foiling, which is actually kind of nice. We just have one factor over here, so we're just going to distribute 4x squared plus 2x minus, and then the bracket, we just have to distribute that 2. It's okay that it's in the back. That's no problem at all. So 2x squared minus 4. Okay, now here's where I take the shortcut, but I need to make sure that I distribute that negative. That's so important. So 4x squared plus 2x minus 2x squared plus 4. Make sure that we put those brackets there. We got to make sure we use them. Change every sign after. We can, right? We can collect like terms here. We can put those two together. So 2x squared plus 2x plus 4, and then just don't forget your bottom, 2x plus 1 squared. You don't really have to factor the top. If you want to, you can. If for some reason the top factored to a 2x plus 1, then we could maybe do some canceling, but that just happens so little that we don't have to worry about that, okay? Like I said, I think that comes up when it gets a little harder, and we'll talk about it then. Okay, so that's our derivative. That one wasn't too bad. And what does that find us? That would find a slope on that original graph. All right, let's do one. We got 2 more. We can make it do 2 more. We'll be good. This one's kind of in between, because let's take a look. Why do we know this is harder? F of x equals the square root of x plus 2 over the square root of x plus 1. Now we didn't bring in, I didn't bring in trig. So we're doing this one more day, so we'll hit some trigs with fractions tomorrow. In case you're disappointed, you haven't forgot about trig, we'll bring them in tomorrow. We got to add the other parts of trig, and then I think we'll see maybe one fraction. That was one of those. All right. Probably want to rewrite this, right? Before we even start, how am I going to rewrite this? X to the 1/2, right? A square root is the same as a 1/2 power. And then same thing, x to the 1/2 plus 1. Can my x to the 1/2, or even over here, can my square roots cancel? Not if it's attached to addition or subtraction. If this was multiplication, crossing it out, whole different story, okay? Remember, that went back to why we like multiplication over addition, but here it's got to stay. So let's just take our time now. Again, this f of x is not representing the whole function. It is just representing the numerator. Okay, it's just our easy way to always say f of x, g of x. All right, so f of x is x to the 1/2 plus 2. What is its derivative? Roll it down, so we have 1/2. And then if I subtract 1, it takes me to x to the negative 1/2. 1/2 minus 1, but at least the derivative of 2 is 0. All right, g of x, which we put, are we okay on that? We get to practice it again, so we can't go wrong. G of x is x to the 1/2 plus 1. And actually, look at this. What is its derivative? It's actually the same thing, yeah, because we don't care. Those constants don't affect the derivative. So roll it down, so we get to practice it again. At least roll it down 1/2. And then x to the, if I subtract 1, just take your time. If you're going to always mess it up and you just want to type it into your calculator, that's fine. 1/2 minus 1 gives us negative 1/2. 1/2, if you want to do something with 0.5, you can. And you just have to be careful. 1/3, you can't just do 0.3, right? If it's a repeating decimal, then you have to use a fraction or it'll be slightly off. All right, here we go. What is it? G's, right? G's on the corners, okay? G's on the corners. So G, derivative of f, minus bracket, if I can remember to use it, f, then my derivative of g on the corner, and then on the bottom corner of my triangle is g again, but I had to square it. G's on the corner, each one is different. All right, so let's do, then it's just a matter of plugging it in. G is, can we see it? I'm gonna slide it up. Okay, so let's officially mark this as our derivative. G is what? X to the 1/2 plus 1. Derivative, we said we can't go wrong, 1/2 x to the negative 1/2. I could put that in parentheses, but notice there's no plus, so that's just one group. So I don't have to FOIL. I'm just distributing this to both of them. Minus bracket, and then kind of the same thing. F is x to the 1/2 plus 2. I wish I had my board. Okay, we can do this. Because I have to put in there times the derivative of g, which was that 1/2 x to the negative 1/2. Bracket goes there. All right, and then don't forget all over our g. Here, if you want to go back, it's up to you. You can definitely write it as x to the 1/2. If you just want to write it as the square root of x plus 1 and squared, that's fine. Doesn't matter. Same thing. Does this square and this square root cancel? No, because of that plus 1. All right. So now we want to, this is a whole group. There's no plus here. So we're taking this whole thing to both of these and we're done. All right. So what happens when it goes to x to the 1/2? We multiply the numbers in front. What's 1/2 plus a negative 1/2, 0. Anything to the 0 power is 1. So that actually just drops out. Or well, the x part. And then this times 1, that's just the 1/2 x to the negative 1/2. All right, minus, and then our bracket, same thing here. This is just going here and then here. Do the numbers in front, 1/2 and 1. There's a 1 there in front. All right, and then when we multiply the x's, we add the exponents, which takes us to 0. So x to the 0 is 1. Okay, then this plus right here. What happens here when we multiply? 1/2 times 2, that's 1. So that's kind of nice, but then we still have x to the negative 1/2. Let's use those brackets. So make sure we distribute, make sure that I change every sign. Oh, this is kind of cool. So this should be a negative 1/2, and then make sure that this is a negative x to the negative 1. And side up. Now, what if should we bring it in? Let's bring this in sooner than later. Don't forget we've got this guy. Only because you see how in the numerator I'm already having fractions. So I want to make sure that I don't forget this bottom. Because once we see a lot of fractions, then we just totally drop that last guy off. But what happens here? 1/2 and negative 1/2. Come on, so at least that's good. And these guys are like terms. So 1/2, and now that I distributed a negative 1, 1/2 minus 1 gives us negative 1/2 x to the negative 1/2. When you're adding, you simply do the numbers in front, the exponent stays. Okay, and then we have our bottom. Not a bad answer, not a bad answer. We just don't like the fractions in the fractions. If it's possible to change that, we could. So this, do you see how this 2 is on the bottom? Let's officially put it on the bottom. So I'm gonna have the negative 1 stay on the top. I'm gonna move this 2 to the bottom. And since I'm moving stuff around, this is negative. Where could that x go? X could go on the bottom. I could write it as x to the 1/2, or I could write it as the square root of x. Those two are the same thing. And then I still have square root of x plus 1 squared. That's probably a better answer. I mean, I probably wouldn't take off for this. I wouldn't. But since there's a fraction and a fraction, then we usually like to just make it a little bit more organized. Okay. Exponent here of both of those of 1/2 would be fine. You can't, how come you can't distribute this in? How come we can't distribute that in? Because we have the exponent. So you'd have to first write that out twice in FOIL and then distribute, and it just doesn't serve a purpose. Okay? This is actually more condensed, which is actually nice. Now, can we see that? It's a variation of that one. All right, so take your time with those negatives. All right, let's try this last one. This last one, we're actually going to use our equation, okay? Most of the time, it takes a lot of work. And so I know it's kind of, but I don't want you to forget why we're finding it. So there is one on the homework that says, find an equation of the tangent line. Of the tangent line. Trying to see if we could avoid this, but we'll just write it. To the given curve at the given point. So we're going to actually go write the equation of the tangent line or to the given curve at the given point. All right, so here's, oh, let me pause. Let's see, can you see it? Yeah. Slide up just a little. All right, so of course it's got to be a fraction, right? X squared plus 1, so we get to use a quotient rule. X squared minus x plus 2, and the point is 1, 1. We got 2/3 of our answer. We're supposed to write the equation of a line at this point. Y minus y1 equals mx minus x1. We can't even mess, I can't even mess it up because they're both 1s. So y minus, make sure you take the y value, mx minus the x value. What do we need? We need slope. What gives us slope? The derivative. Okay, so I want you to at least remember, I do kind of like that he puts these in every so often, just so we remember why we're doing this, right? So we need slope, which means we have to go find derivative. What rule do we have to use? We have to use the quotient rule. Okay, so let's go at it. F of x just stands for our numerator, x squared plus 1. Its derivative, roll it down, subtract 1, number goes away. G is just a little bit longer, right? So G is x squared minus x plus 2, and its derivative, roll it down, subtract 1. Negative x goes to negative 1, and then the 2 goes away. So it's just a little bit longer. Okay, so now our formula for derivative, G's on the corners. So G function, derivative of f, minus bracket f, derivative of G. There's my G's on the corner. And then the last corner of the triangle at the bottom, derivative of x. Well, we got a square. All right, let's sneak it in here. All right, so now it's just a matter of plugging it in. G is the trinomial x squared minus x plus 2. Derivative, that's not too bad. That's just 2x. Okay, that's good. Minus parenthesis. F is the 2 terms, x squared plus 1. And then the derivative is also 2 terms, 2x minus 1. And then G is that trinomial, and I have to square it, but the good thing is I kind of just leave it. Good news, bad news, right? Bad news is kind of messy, but good news is we could just leave it. Okay, so now we just go at it. Now it's a matter of simplifying. Should I go even a little bit higher? Can we go up to there? All right, so just distribute the 2x. We don't have to FOIL that first one, so that's kind of nice. Well, what is it? 2x to the third minus 2x squared plus 4x. Now, is that too quick? Remember, you multiply the numbers in front, add the exponents, okay? Minus this one, what do we have to do? We have to FOIL this. Multiply the numbers in front, add those exponents. So first gives us 2x to the third, outer negative x squared, inner 2x, and last negative 1. All of those are different, so we don't really have to collect like terms. Okay, let's make sure I put into play this, right? So leave the bracket, but now I got to distribute. Let's see if I can make sure I distribute. Negative 2x to the third, positive x squared, negative 2x, and positive 1. Okay, so that was a good one. Make sure that you go through and change every sign. Okay. All right, and then I still should have some room. Okay, so let's do the derivative. Let's collect like terms. This is kind of nice, at least. This drops out. Good. This gives us what? The x squareds give us negative x squared. This 4x, and now since I distributed correctly this time, that gives us negative 2x, so that gives us 4 minus 2, so plus 2x. And then we just have this plus 1, right? So that just kind of take your time, make sure that you have everything accounted for, okay? And don't forget, bring in the denominator if you haven't done that. X squared minus x plus 2 squared. Okay, so that's the derivative. The thing I like about this problem is it reminds us, why do we find that derivative? It's going to find us slope, okay? So m equals, that's what we've been waiting for, right? And what number do I put in for x? 1. And that's just because the point was 1, 1. Take the x value and plug it in. Just be careful here, -1 squared. I don't square that negative. Plus 2 times 1 plus 1. And then 1 squared minus 1 plus 2. And then you square that whole entire answer. So 1 squared is 1, and then it's negative. So -1 plus 2 plus 1. The -1 and +1 cancel out. So we've got a 2 on top. All right. Same thing here, right? 1 squared is 1 minus 1 is 0. So I have the 2 in the parentheses. The only thing I really have is the 2, but I have to square that. So 4. So what's our slope? We did that work for 1/2, right? 0.5. Okay. I think it's a fraction on the homework as well. All right, so now I can go back up here and finally plug in my slope. So I had this to begin with, y minus 1 equals, and now I know it's 1/2 x minus 1. Same thing on the test, and there probably won't be time on the test for you to actually find the line, but I want you to remember, do we see why we found that derivative? It gives us the slope. On the homework, I think they make you distribute and then add 1. We could do that real quick. But it was y minus 1 equals 1/2 x minus 1. Yeah. All right, so if, oh wait, can we see that? Distribute. Say that again. The slope was 1/2. How did we got that? How about, okay, let's check. Did you bring in the bottom? It should have been 2 squared on the.
I got 4 on the bottom.
Okay.
I got 4 on top, but I think the negative one, isn't that supposed to be positive?
This guy.
Is it squared or no? Or does it stay negative?
No, yeah, this right here says I only square the x and that negative tags along out in front. Okay, it's never in parentheses. My coefficient just happened to be -1, and so I'm only squaring then the x.
If the x was like -1,
Then it would have been, yeah, then it would have, yes. So that one was kind of tricky, but because the coefficient has nothing to do with that exponent. Okay, good call. I like it. Good. All right. Okay, so then we just distribute y minus 1 equals 1/2 x, and when we bring it here, it's minus 1/2. But then we add a 1 to both sides, and we get 1/2 x. And then -1/2 plus 1 is 1/2. Can you see that? Okay, so this, whatever our graph looks like, this would be a tangent at the point 1, 1, right? And we just kind of briefly touch it and go up. There's 2 of these on the homework. The last one is extra credit, and I even already made it extra credit, and I went back and I made 2-1 extra credit as well, okay? So it should show, like if you don't, so you have to do 1 through, the last one is extra credit. I'm not sure if it's 1 through 4, 1 through 4, and then 5 is extra credit. Okay, yeah, okay, thank you. 1 through 4 you have to do, and then 5 will be that extra credit. So if you only do 1 through 4, it should show like 100%, and then 5 will just give you the extra credit. What do we think? Questions? We're not sure. Is anyone crying? All right, take a deep breath. Remember, next week, I think it's Wednesday and Thursday. I might push it to Thursday, Friday. We'll see. We're going to have some time to review, okay? Because I want you to see it all together, and then we'll still have 2 days of review before the test, okay? So don't give up yet, okay? All right, see you tomorrow. But don't get behind. Don't try to even do 2. If you don't have time, try to at least do something, okay?